Welcome to the PaLM2 lightning talk. I'm Andrew Dai from Google DeepMind, and I'll be giving a quick overview of PaLM2. So, okay, great. So PaLM2 is essentially built upon previous groundbreaking work in foundation models. So back in 2012, we had the paper, a new approach to large-scale neural networks that was also known as a CAT paper. 2015, we had the sequence-to-sequence learning paper. In 2017, our team, so the Google Brain team, we built the attention is all you need model and paper. So that's also known as the transformer model. And the Google Brain team has also developed several foundation modeling techniques. So these include FLAN, the fine-tuned language models as zero-shot learners paper. This was the predecessor to instruction tuning. Flamingo, a multimodal model. This is from DeepMind that combined vision and language capabilities into one model. And then more recently, Chinchilla, which gives essentially a formula for how you should allocate a certain amount of compute when you're training a large language model. So PaLM2 basically leverages this past history of research, and it improves multilingual reasoning and coding capabilities. It's built on Google's latest JAX and TPU v4 infrastructure on the software and hardware side, and it's both faster and more efficient than PaLM. It's deployed across over 25 Google products now. So here are some examples of what it can do. It has better multilingual understanding. So for example, in this example, it looks like a simple translation, but you can ask PaLM2, can this translation be misunderstood? And PaLM2 gives a more nuanced result, right? It tells you, yes, it can be misunderstood, because it could be, because when you say I don't understand anything, it could be misinterpreted as meaning I only understand train stations. Also in reasoning, PaLM2 is better than PaLM. So here we have 4 cars, each a different color. And we ask the model what is the actual order of the cars if we only tell the model the relationships between any 2 cars. So this is a simple logic puzzle. And it can also do coding, but not only coding, but multilingual coding. So here we have some buggy code, and we ask PaLM2 to fix the code and add line-by-line comments in Korean. So in this part below, you can see it's fixed, and also now there are comments in Korean that explain what each line means. And as I said before, it's now available in over 25 products and features, including YouTube, Gmail, Workspace, Android, Bard. And what is behind this? Well, previously at Google and in probably many other organizations, separate small models were used and trained for each language understanding task. But PaLM2 essentially unifies all these problems and tasks into one large model. So it can do language understanding, generation, but also translation and multilingual problems. And as well, it performs well on math and code. And we see a lot of benefits in putting all of these capabilities into one model rather than spreading them out into smaller individual models, which was the previous way of doing things. In terms of architecture, typical large language models, such as GPT-3, use a single language modeling or mass language modeling objective in the case of BERT. In PaLM2, we use a tuned mixture of various pre-training objectives, similar to the UL2 paper. We also use an improved transformer architecture compared to PaLM. And finally, one of the most important things is that we scale the data and the model size in a roughly 1-to-1 ratio. And this is following the results of the Chinchilla paper from DeepMind. previous models, such as PaLM and others, typically scaled model and data in a 3-to-1 ratio. And the problem with this is that your model gets much bigger, which makes your inference cost, latency, and all those things worse, while I will show later it's even actually worse at the tasks that you care about. And then on the data side, previous LLMs typically use a mostly English data set. I think there's some assumption that the English web might be more rich than other languages. But in PaLM2, we use a much more multilingual and diverse data set compared to PaLM. That includes hundreds of languages. We use more code and math data than PaLM. And we add parallel multilingual data, which means that the model is actually able to do translation without any additional fine-tuning. So as soon as we trained it, it could do translation out of the box, essentially. And it's able to do all this without any damage to English benchmarks. So English performance is still state-of-the-art. Finally, we, as a research project, we added control tokens during training to allow toxicity control to be done at inference time. These are some of the results that we obtained during the project. So these are scaling law plots. So following the approach in Chinchilla, we independently derive scaling laws. And what this shows is in the y-axis, this is the loss on a standard data set. You can think of this as a language modeling loss. And x-axis is the number of parameters in the model. And these different colored lines indicate how much loss you get with this much compute. So the blue line, if we had a compute budget of 1E19, what is the minimum loss if you vary that compute between the number of parameters in your model and the amount of data you train on? This black line is the fit with the scaling law we derived. And this black line essentially is a prediction if you assume that compute should be allocated evenly between the number of parameters and the size of the data. And Chinchilla has a very similar result as well. Now, in terms of the actual downstream benchmarks of PaLM2, on multilingual tests, we evaluated PaLM2 on professional exams. For Chinese, this was the HSK exam. For Japanese, this is the J test. Italian, we used PLIDA. French, we used TCF. And for Spanish, we used DELE. For the multiple choice questions, we used the correct answers. And for the written exams, we used a set of highly qualified raters who speak that in their native language. And in this chart, you can see here, blue is PaLM2, red is PaLM. And PaLM fails several of these tests, such as Chinese and Japanese. But PaLM2 passes all of these at the professional level. So in several of these languages, PaLM2 can be qualified enough to teach that language. But of course, this is only for reading and writing. We didn't evaluate any of the listening or speaking tests, since PaLM2 is not natively multimodal. Another added benefit of natively multilingual model is that PaLM2 is very good at cross-lingual tasks. So you can think of PaLM2 as a speaker that naturally knows many languages natively. And of course, there aren't many people like that in the world. But that enables it to do things like this, where you can ask PaLM2 to explain the meaning of a Persian proverb. Here, this is I guess this is transliterated Persian proverb, and it writes the answer in Persian. But you can ask it directly, what is the Russian equivalent of the proverb? So the input is Persian, the command is English, and the output is Russian, right? Which is very nice. And then you can ask it, well, I want to know a similar proverb in Arabic. So it naturally kind of internalizes all of these languages at the same time. There's no need to call out to like a separate translation module or anything. In reasoning, PaLM2 significantly outperforms PaLM, particularly on Big Bench Hard, which is this collection of data created by volunteers around the world. And this is a very nice benchmark because it has something called a sentinel token, which means we can check that it's not in the training data. And when we build the training data, we are very careful to make sure this is not in there. Whereas like with some of these other benchmarks, it's well known that these academic data sets are essentially tainted because they're in the training data of things like GPT and previous models. So if we look at these results, PaLM2 is significantly better than PaLM in several of these, and is competitive against GPT-4 as well. And the SOTA results here are on models that have been fine-tuned. So SOTA is fine-tuned, and these other 3 columns are just large language models. On math as well, PaLM2 does very well. So on the GSM 8K set, PaLM2 is state-of-the-art. And it does very well on the other standard math data sets like math and MGSM. And then on translation, we see that actually PaLM2 outperforms Google Translate. So you can see here, PaLM2 is significantly better on Chinese to English, and also English to German, and also better on dialect translation with dialects. So in this case, we tested with Brazilian Portuguese and Portugal Portuguese, and also mainland Chinese and Taiwan Chinese. And this is, again, without fine-tuning on the specialized data sets that Google Translate have. Another key aspect about PaLM2 is that because we didn't use a purely language modeling technique, like in the standard models, we actually find that PaLM2 memorizes less than PaLM. And this is very useful because we don't want large language models to simply repeat verbatim from the training data sets, right? And we do see that with some large language models. So you can see here that the amount of the training data that the model has verbatim memorized is significantly lower than PaLM2. And that PaLM2, the amount of memorization per number of repetitions of the data is shown here. So if the data isn't repeated very much, like if the model only sees the data once through up to like 5 times, the model has a low chance of memorization, which is a solid line here, compared to PaLM, which is a dotted line. And then if the data is repeated many, many times, then PaLM2 memorizes better than PaLM. And this is kind of usually the behavior that you want, because data that only appears once usually isn't very useful, whereas data that, knowledge that is appearing many times over the web is usually knowledge that you want your model to know and be able to recite if needed. So you can think of things like Bible passages or quotes in that realm. And then PaLM2 is a very strong model in terms of its zero-shot capabilities. So this is even before any kind of fine-tuning, instruction fine-tuning that is. So basically at the end of training, we took the PaLM2 checkpoint. And of course, all it's seen is the web and various things. And we just asked it, write an advert to see my pastries. And even with this very simple prompt, it's already outputting Markdown. You can see here it's outputting bold headings Markdown, and also lists with these kinds of bolded parts. And there's a lot of structure to it. So it's already coming up with a headline, mouth-watering pastries that will tantalize your taste buds, a body, our pastries are made with the freshest ingredients, and then a list of very nice and tasty sounding pastries like croissants, pain au chocolat, and danishes. And I haven't included here, but there's also a section later down that has savory pastries. And it's able to do all of this without any prompting about what Markdown is or how to structure this kind of thing. So that's very nice. So in conclusion, PaLM 2 is a smaller, faster, and more capable model compared to PaLM. It's available in 4 sizes. So Gecko is the smallest model. That's small enough to be on device. Then there is Otter and Bison. And I think Gecko and Bison are the ones available through the API right now. And then Unicorn is our largest model. And that's where all the benchmark numbers and this zero-shot example is from. That is all from the Unicorn model. These models are available via the PaLM API and the Vertex API. And these models are already powering what you see when you go to Google Bard, though Google Bard doesn't use the Unicorn model. Google SGE, which is the Search Generative Experience, MedPaLM 2, SecPaLM, Workspace, and many other products at Google. And I should mention that the benchmark results you saw in earlier slides, you might not necessarily see through the API because the API has gone through additional instruction fine-tuning and safety tuning that we didn't have when we have the results in these slides and in the tech report. And you can find the tech report on archive at this link.